Hi everyone. This week we're going to work some more with clocks and we're going to use what we know about telling time, the number of minutes in an hour, to do some real life problem solving, thinking about schedules and how we plan and get ready for a day or to get somewhere, and all those things that it is important that we know how to plan for. All right, so let's get going. This portion is for Monday, May 18th. Times and schedules. Have you ever planned a trip? Even if it's a trip to go to the library or get to the museum. Sometimes we need to be somewhere by a certain time. Maybe it's school, a play date, a movie, an appointment. Maybe it's your scheduled snack time while you're at home working on schoolwork. So we have to figure out ways to determine what time to leave or what time to finish something by. Those are the sorts of problems we're going to be working on this week. Here's a bus schedule. It's for the Metro bus route 48. It serves Mount Baker and heads to the University District, and from the University District back to the Mount Baker neighborhood. I know some of you are familiar with the Mount Baker neighborhood. All right, so we can see here at the top, in this top box, this is where it's explaining to us where the stop is. Let me find a color to use that will show up on there. Purple. So up here, we're looking at the stop. So this is Rainier Avenue and Forest Street. This next stop says 23rd and South Jackson. The next one is 23rd and East John. This next one is Montlake Boulevard at 520. And this final stop is in the U District on 15th and 42nd. So if we looked at 23rd and Jackson, these are the times that the bus is going to approximately leave that area. So right down here. And I can tell that because this part says 23rd and Jackson up here. What time would I need to plan to get on the bus or be ready for a bus in order to get to the U District by 9 a.m.? Can you see? So if I got on the bus, for example, at 8:07, I would get to the U District over here. And remember, this is the last column, the stop we're looking for. We would get to the U District about 8:25. I would definitely be there by 9 a.m. But maybe I was running a little bit late. So I got on at 8:20 right here. I should get to the U District at about 8:38. I'm also there by 9 o'clock. But maybe I'm somebody who's running a little bit late. I don't need to be there. I just need to be there by 9. So maybe I would take the 8:38 bus right here. And I would arrive at the U District around 8:56, which is 4 minutes before 9, which that would help me get there in time. So we're going to look a little bit about what it means to tell time to the nearest minute. You might remember that from the bus schedule, times were not just at the 5-minute mark. So they weren't just all like 8:15 or 10:15. They were more like 8:38, numbers like that. So it is important for you to be able to tell time to the nearest minute. And you practiced some of this last week. Remember, this is one group of 5 minutes. So that's 5 minutes right there. So when we get over to the 9, this is 9 groups of 5 minutes. So you can see that that's going to be 45 minutes. Let's see if we can write that over here. Might be a little hard to see. So that's 45 minutes right there. As the minute hand goes past the 9, this is going to be 46, 47, 48, 49, and then we're at 50 minutes. So those are important to remember, that those are counting by 1-minute increments in between, but between each number on the clock, as we go from the 9 to the 10, that's a 5-minute span of time. So we'll work carefully to make sure that we're getting close to the nearest minute. Can you see the connection between a clock and a number line? We've worked with number lines all year with so many different things. And you can see here that there's my number line with my partition parts, and here is my clock. Can you imagine if I was able to cut this clock right here? Just cut it right in this spot. I put some scissors over there for you to see it. And I could say, oh, that clock is being cut at, let's say it was being cut at the 4 o'clock mark. So over on my number line, I can imagine that here is 4 o'clock. Then I could have 5 o'clock. We could have, write some up here, 5 o'clock, 6 o'clock, and so on. You could even think of in between, midway, so this one would be 7 o'clock here, if I'm going by hours. Midway in between, I'm going to draw it down here, would be 7:30, because you know that's halfway through the hour. So that's how we can make a connection from a number line and a clock. And I think that it's a little bit easier to think of a clock and the minutes and the time on a number line, and you'll see as we move forward this week how helpful of a strategy that will be in solving your problems. So determining the time between two events, a start and an end time, we also call that elapsed time, or how much time has passed. So that's what you're going to be focused on this week. Some things and types of questions we might be thinking about, these play a part in our daily living often. How long will the activity take? How much longer until we're there? Anybody ever heard that in a car ride? What time does it start? What time does it end? How long did it last? How much time do I have to finish this? Maybe some of you, as you're working on your work at home, you're thinking, how much longer do I have to keep working on this? How much longer will Miss Krista Thulu keep talking on her video? I'm going to keep going. We're going to work together to complete this movie schedule. So as you can see, one column has the movie. The second column has a start time of the movie. Then we have the end time of the movie and the duration of the movie. That word might be less familiar to you. So it's like thinking duration is how long it lasts. Oops, that's sloppy. You know, it's getting better, but it's not my favorite. So that's the same idea as duration. So we have 5 movies listed here: Alvin and the Chipmunks, Harry Potter, Ice Age, The Muppets, and The Smurfs. So you see those 5 movies listed over here. Some of them you can see we have the start time, but not an end time, but we know how long the movie lasted. While others we might not, like down here with the Muppets, we do not have the start time. We know when it ends, and we know how long it lasts. So we're going to be able to figure all of this out. I took apart this chart so we can work on them 1 or 2 at a time and use that number line strategy to help us. And here you can see we have the first 2 movies that were on the movie schedule. The first one, Alvin and the Chipmunks. Second one is Harry Potter. The part I didn't copy over, which might be helpful to remember, is that this is the column for start. This is the column for end time. And this is the duration. So for Alvin and the Chipmunks, I'm going to go ahead and draw a number line up here. Let's see. Actually, I'll put it down here. So on our number line, we can add the start and the end, and we know for this one the duration. So I know what time it's going to start. I'm looking for what time it ends. That's my question. So I'm going to go ahead and do some writing on here. It started at 12:15, and it lasts an hour, 10 minutes. Can you envision yourself jumping ahead 60 minutes? What is 12:15 plus 1 hour? Do you know where you would land? You're right. So we don't change the minutes, we just change the hour. And after 12 o'clock, remember, we start back at 1. Oh, did you catch my mistake? I almost didn't. It's not 1 o'clock because it was an hour from 12:15. So that actually is 1:15. So I took care of this hour of the movie, but I didn't take care of the 10 minutes. So I'll go ahead and make this jump here. My spacing isn't great, but it's the best it's going to be right now. So we have to go ahead 10 more minutes in order to finish that movie. So 1:15 plus 10 minutes would get us to 1:25. So that means Alvin and the Chipmunks ended at 1:25. All right, let's do one for the Harry Potter movie. So we need a number line. I'm going to make it down here. We're going to think about our start, our end time, and our duration. Which one are we solving for this time? You're right, we're solving for the duration. So I'm going to go back. Here's our start. We know that it starts at 2:34 and that it ends at 4:34. So we're going to have to figure out what is the distance between those. So the start is 2:34. The end is 4:34. Did anybody notice anything about those two times? Oops, it's not liking my hand resting on there. I hope you noticed that. Did you see it? 34 and 34. So it's just going to be our hours. We're not going to have a number of minutes. That makes me pretty happy. So I'm going to look at this by thinking that I can jump ahead an hour. Keep track of it because that's what we're looking for. When I jump ahead 1 hour, I've landed at 3:34. I need to jump ahead another hour, which will land me at 4:34. Remember, what we're looking for is how long the movie lasted, and we can see here that it lasted 2 hours, so I can record that up here on our chart. Great, let's look at the next movie. Here we have Ice Age, and we can see that we need to find its end time. It lasted 90 minutes, so let's see what will happen for us with that problem. So I'm going to make this number line above here. And we'll need to have our start time. We're looking for the end time, and we know it lasts 90 minutes. So let's see what happens. It starts at 4:30. Oops. At 4:30. And it goes 90 minutes. What do you know about 90 minutes? Before we think about that, we might think about what do we know can make 90 in a number bond? How many minutes are in an hour? That will help us. 60, you're right. So 60 and what make 90? 60 and 30. So 90 minutes is another way of saying an hour and a half, because here's your hour and here is your half hour. Kind of hard to read what that is. So this was an hour. 1 hour. And the other one's a half hour. So we know then that from 4:30 to, that might go away. Try that again. If I move ahead 1 hour or 60 minutes, that I will land at 5:30. We still need to go that 30 minutes though, so we're going to go jump ahead the 30 minutes, also known as a half hour. Do you see where that would land you? You're right. That lands us at 6:30. So that would be the end time of Ice Age. Okay, I'm going to go ahead. Let's go down and look at the Muppets. So the Muppets, do we know the start time? We don't know when it started. We do know when it ends, right there, and we do know how long it lasted. So we're going to work in reverse. I'm going to put our end time, because that's later, so down the number line, than our start time. It lasted an hour and 20 minutes. I'm looking at the number I'm working with. Since it's 7:20, I can take care of that 20 minutes first. So I'm going to take out the 20 minutes. Do you see where that would land us? 7 o'clock. Now we're going to take out the hour, and that would get us back to the start time. So we took out 1 hour. And you will see now that that would take you to 6 o'clock. So I can write that right in here. The Muppet started at 6.
The final problem we have to work on is the Smurfs. The Smurfs, we know the start, we know the end. We have to find the duration, or how long that movie lasted. So I'm going to fill in the start, which was 7:30, and we're going to fill in the end, which was 8:47. We have to think about a jump I could take. Does anybody feel like they could jump an hour? I think ahead. I'm thinking if I can jump an hour, I'm good at adding an hour, and that gets me close to 8:47, but not beyond it. So if I jump 1 hour forward from 7:30, that is 8:30. Now you might want to do a couple of different things. Some people might see this as a jump of 17. Some people might see it a jump of 10 and then 7. Whatever works for you. For my space, I saw that it was a jump of 17, so I'm just going to do that. And we know that's 17 minutes. So this movie lasted 1 hour, 17 minutes. If any part of this was unclear or how I hopped on those number lines didn't make sense, you can always go back and rewatch portions. Let's go ahead and fill in the chart neater. So here we are. We have Alvin and the Chipmunks. It lasted 1 hour and 10 minutes. That means that this movie ended at 1:25. Harry Potter started at 2:34 and ended at 4:34, so that tells us the duration or the length of that movie was 2 hours. Ice Age started at 4:30, was 1 hour and a half long, otherwise known as 90 minutes. So remember, this is 1.5 hours. So it started at 4:30 and it lasted for 1 hour and a half, so that tells us that it ended at 6 o'clock. The Muppets, we needed to figure out what time that started. It started at 6 o'clock. And then we have the Smurfs. Started at 7:30, it went till 8:47, so we know that that lasted 1 hour, 17 minutes. I hope that made sense. All right, here's your practice for today on your own. In your workbook, please go ahead and work on pages 155 to 156. Just do the odd problems so that you don't have to spend too much time in there. Review those with somebody at home. On Seesaw, you're going to see an elapsed time practice problem, so I can see how you're thinking about those. You'll also have an exit ticket on Seesaw, and you know what to do there. I put a little stop sign at the bottom of this page because I'd love it if you stopped here and came back tomorrow for Tuesday. All right, we're back. It's Tuesday, May 19th. Go ahead and start here, and we will work through some more time story problems using that open number line to help us find the elapsed time. Okay, depending on what type of problem or times you're working with will depend on the number line you have. So if you can notice here that this first number line, just put 1 by it, we see that it's labeled with 3:30 and 4. Our second number line is also labeled with 3:30 and 4. Similarly, our third number line is labeled with 3:30 and 4. But I bet you notice a big difference. So they're not at the same, 4 o'clock's not at the same location, and there's different marks between them, or not. So if I look at this first number line, I can see that we're going, if we go from 3:30 to 4, that means this next hop, they're all the same type of hops because they're equally partitioned out. Can you see what we're adding each time? We're going from 3:30 to 4, that's 30 minutes. So you would see that next would be 4:30, and then we would have 5 o'clock, and then we would have 5:30, and then we would have 6 o'clock, and so on. Does that make sense? Then I look down at the second number line, and I think, okay, we're going from 3:30 to 4 again, but what are the intervals that we're jumping by now? So it's 1, 2, 3, 4, 5, 6. What could that be? How do 6 and 30 go together? Because I know this whole jump is 30. Yeah, 5. Let's see if 5 minutes works. So this would be 3:35. I'm going to test it before I write them all in. 3:40, 3:45, 3:50, 3:55, and 4 o'clock. Because remember, in time, after 60 is when we regroup to an hour. So it's different from other numbers we're used to working with when we regroup when we get to 10. Okay, so let's see. So this is going to be 3:40. So if we were working with smaller number chunks like this would be a helpful number line. So for this last one, what do you think it would be? We're going from 3:30 to 4 with one stop in the middle. What's midway between there? You're right, that would be 3:45. So our jumps on here are 15 minutes. So every time we jump on this number line, we move ahead 15 minutes. So this would be 4:15. This would be 4:30. Then we go to 4:45. Then we go to 5 o'clock. So depending on your situation, depends on the type of number line you might end up using. When we're working to find a lapse time, you'll notice that we're working with number lines. We call them an open number line because we can start wherever we like and end wherever we need. We're really focused on that start time on the number line and the end time on the number line. The distance between is how long something lasts or how long something took. So let's find the elapsed time for, let's see, whatever the situation would be. Let's say it could be a movie. It could be, let's say you started reading a book and it was really good. And you started reading it at 2:16. Kind of a random time, but that's when you started. So remember our start, because the time will be later at the end. So we want to put the larger number or the end time there because we've moved later in the day. So you started here at 2:16 and you kept reading and reading and reading. You finished the book and you looked at the clock and it was 4:32. I bet you were hungry too. We want to know, how long did it take? What's the distance between 2:16 and 4:32? Just like other times we've used number lines, there's so many ways you could do this. Some of you are going to look at these minutes and go, I wish the ones place had the same number of minutes. Some of you are going to go, I'm going to add an hour. Let's add an hour. I'll start with that. So if I add 1 hour, we're at 3:16. That was helpful. You can add another hour and not go beyond when I was done reading. If you read more than 1 hour, you read more than 2 hours. So that would land you at 4:16. And now we need to find out the distance from 4:16 to 4:32. So if I add 20, that would take me to 4:36, and that's too much. So I'm going to add 10 minutes. I'm trying to put my labels of whether it's an hour or minutes so I can keep track of that. So there I'm that, ooh, look at that, a 6 here and a 2 here, because 6 and 6 is 12. So I know I need to add 6 more minutes. And that lands me at 4:32. But I'm not done yet. I haven't answered the question. So we can go back and look here and say, okay, I went 1 hour, 2 hours, and then the 10 and the 6 minutes together is 16 minutes. So the duration would be I'll put it down here. Read 4, because we made up a story as we went. 2 hours, 16 minutes. Oops, I don't actually want to write it that way. And I'm laughing in my head right now because 2:16 is the time you started reading too. This is how this should be written. For 2 hours, 16 minutes. I'm not really sure how that ended up that way. Okay, let's look at some more problems we can solve. We're looking at another chart. This is a family's chart of the bathroom schedule. That's a busy household with, I'm looking from the bottom up. We have Grandpa, Dad, Mom, baby Georgie, Carl, and Megan. So there's a lot of people that need to get in and get out and get ready for their day. So this is the schedule. So kind of like the movie schedule from yesterday, we have a start, an end time, and the time taken, or duration. So we're going to work to fill this chart out. I broke it into smaller parts. So let's look at Megan and Carl first. So we have that whole idea of a number line. So for Megan, make an M, make her number line. We know her end time is 6:30, and that she is in the bathroom for 30 minutes, or let's remind ourselves, that's 30 minutes. And so if we go back 30 minutes, that will take us, sorry, my jump disappeared. There we go. Back 30 minutes, that will tell us what time she started in the bathroom. And she would have started at 6 o'clock in the bathroom. Then we have Carl. So Carl is going in to shower and brush his teeth. He goes in there at 6:30 to start his getting ready process. And he comes out at 6:56. So how long did Carl spend using the bathroom to get ready? So we're going to go ahead and jump. I would jump, maybe you want to jump 10 minutes. And you would land at 6:40. 10 more minutes. Label your jumps. 6:50. And then you can see that you need to jump 6 more minutes. And you can see from this 10, 10, and 6, that would be 26 minutes that Carl used the bathroom. Let's look at some other family members. Baby Georgie. I wonder how young of a baby Georgie is. Is he taking a bath by himself or somebody helping him? Just my question. All right, let's look at Georgie. Georgie gets started in the bathroom at 6:56. And his time is 24 minutes in the bathroom. I'll erase a little bit of that so we can see that. 24 minutes. So we want to add 24 minutes. I feel like I would like to break that up into a 4-minute jump first. Do you see why I chose 4 minutes? Remember, as a mathematician, you want to be a thinker. When I add 4 to 56, I get to the next group. So that would be 60. But 60 minutes, remember, that's a new hour. So we're going to be at 7 o'clock. And I've added the 4 minutes. I just have to add the 20. So now we can see that Georgie's done in the bathroom at 7:20. Let's see what happens for Mom. I just automatically am going to draw that number line. She's in there for 3/4 of an hour. What is 3/4 of an hour? She comes out at 8:05. Any questions about 3/4 of an hour? So let's think about our clock. Let's see, I need a little space up here. Think about your round clock. If I partitioned my clock into fourths, this would be 1/4 of the hour. This would be 2/4 of the hour. This would be 3/4 of the hour. Can you now see what time this would be over here? If you're envisioning the 9 on our analog clock, you're right. 9 groups of 5, so that's 45 minutes. So 3/4 of an hour, half an hour is 30 down here. A quarter of an hour is 15 minutes. A full hour is 60, 4/4, and 45 minutes makes 3/4 of an hour. So don't let the words throw you off. So she's in there showering, brushing her teeth for 45 minutes. So I see that she comes out at 8:05. I need to take out 45 minutes, which was 3/4 of an hour. So maybe my first jump is going to be 5 minutes to get rid of that 5. So that gets me to 8 o'clock. From 8 o'clock, I still need to, so here's my little 45 over here. Used 5. Would you be comfortable taking out 30 minutes? It's kind of tricky to think about this. So if I go back a minute, I'm before 8 o'clock. So if I go back 30 minutes, that means I'm in the 7 o'clock hour, and it's halfway between, because it's a half hour, so it's at 7:30. So do you see that we have 10 more minutes we need to take out? Minus 10. Mom was able to get into the bathroom at 7. Nope. She was able to get in the bathroom at 7:20. All right, we have a couple more family members to go. Dad. So Dad goes in at 8:05. And we know that he is done at 8:47. See where I'm getting this information? Ooh, that 5 is terrible. Better. So let's see. We're trying to look for the duration or how long he spent in there. Let's add 30 minutes. Good place to start. So now I'm at 8:35. But I need to get to 8:47. If I go 10 more minutes, 12 more minutes. Do you see how that would get us to 8:47? So we can see that altogether, Dad spent 42 minutes. 42 minutes in the bathroom. Now let's work on Grandpa's time. He ended up last. So we know that he starts in there at 8:47 and that he spends 35 minutes in there. So let's move ahead 3 minutes to get rid of the 47. So now we're at 8:50 and I'm going to make a number bond over here. So use 3. Use 3. I want to move ahead. I don't know, let's do 10 minutes to get to 9 o'clock. 9 o'clock. So now I've used 10. I still have 20 more to go. I can do that. So let's do 20. That's 20 minutes. So now we're at 9:20. Do you see that? We moved ahead 3 minutes to 8:50. 8:50 plus 10 minutes was 9 o'clock. 9 o'clock plus 20 minutes was 9:20. So now, if I keep track with my number bond over here, we've used 33 minutes. I have 2 more minutes to use, plus 2. So he would land at 9:22. So Grandpa is done at 9:22. Let's go ahead and fill that in on our data table. So Megan went into the shower at 6 o'clock. She was done at 6:30. It took her a half hour. Carl was in there at 6:30. He was ended at 6:56, and that took him 26 minutes. So that's the duration. So then we have baby Georgie is in there at 6:56, comes out at 7:20. That was 24 minutes together. We figured out that he came out at 7:20. 7:20, Mom goes in. She starts there because she's in there for 3/4 of an hour. Remember that we talked about 3/4 is the same as 45 minutes. And then we have Dad and Grandpa too. Today on Seesaw, you're going to work on this problem. I left part of it blank. I just wanted we hadn't really talked about hours jumping like this, but I know that you can make this work. So if a supermarket opens at some time in the morning, this tells us it's morning, and it stays open for 14 hours, 30 minutes. 14 hours is quite a long time. Let's say it opened at, let's see, I want to make a number line. We're just going for start and end time. You're going to know the start You won't know the end. That's what you're looking for, but you know the duration, how long the space between this is. If we, let's say, I'm trying to think of a time from the other page. Let's say it was 8:05 when the store opened. Can you, if you add 14 to 8:05, what do you get? Anybody else get 22? Isn't that kind of a funny number for time? Why is that? Yeah, because after 12 o'clock, remember we go, I'm just going to start. We go 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, then 1 o'clock. So you'll notice that right here, something happens. We start over. So we work in these 12-hour segments. So if you're adding 14 hours, you're going to have to be really a little bit more careful. So I don't want to go past 12 o'clock yet. So I'm going to add, I could just add 2 hours. Let me do that. That would get me to 10:05. I probably should switch colors to help you see the difference. 10:05. If I add another 2 hours, I'm going to think ahead. Will that get me, gets me past 12, but I'm still in the 12 o'clock hour. 12:05. So now I've taken care. Do you see how that is important? Could I add 10 to this? Because I've used all those? Maybe. That would again get me to that 22 hours thing. So I would go ahead and add, no, it wouldn't. I messed that up, but here, let's add 5 hours. So 1 hour, well, maybe we should just add 1 hour. I'm messing it up. Let's go 1 hour, that'll be helpful. Now you can see it's actually 1:05. And then you would add, you have 9 hours left to add. So 9 and 1. Then we would be at 10:05. I just made another mistake though. I didn't add the 30 minutes. I could do that down here. So 10:05 plus 30 minutes would be 10:35. That's not the time the store opens in the problem that you'll see, but I just wanted you to see how it's important to add your hours in smaller increments so that you can keep track of when you're going to shift beyond 12 and regroup to that 1 o'clock hour. All right, let's review what you'll work. Okay, you're going to work on Math and Focus Workbook B, page 155 to 156, evens only. Review that with somebody at home. Seesaw will be that problem we just reviewed, and an exit ticket. This week I'm going to put up 6 math tiles. Some of you are going to be overwhelmed by that. Some of you might be excited by that. Take your time, save them as a draft. Go ahead and stop here and come back for Wednesday. Welcome back, everyone. We're on Wednesday. Today we're just going to work on a few problems together, and then you'll have some time to practice on your own. All right, here's a problem. Tom fell asleep at 10:45 p.m. He woke up when the alarm clock went off at 6:30 a.m. How long did Tom sleep? Always using those strategies of rereading problems. So let's look at it again. Tom fell asleep at 10:45 p.m. I'll underline as I go. He woke up when the alarm clock went off at 6:30 a.m. How long did Tom sleep? To me, it appears that we know our start time and our end time, and that we're looking for duration, how long of a span that was. I also can see that maybe I should write a sentence to solve my problem for my answer. Keep talking about this. Here, I'm going to go ahead and turn that right into my sentence of my own. Tom slept. Tom slept. I have a feeling I'm going to say hours, minutes. There we go. So let's go ahead and make our number line. We have our start and our end. Do you see that we're going to cross that 12 o'clock mark again? Which can make things a little bit tricky, can't it? So let's see. we know that Tom went to sleep at 10:45 and that he woke up at 6:30. If I go ahead 2 hours, that takes me into the midnight hours, but at 12:45 because the minutes didn't change. So it's 12:45. And this is where it can get a little bit tricky because we're not used to starting over. So when you add the 15 minutes or that quarter of an hour, ooh, labels are going to be important here. Minutes, hours. Instead of going to 13 hours, we're going to go to 1 o'clock. Okay? Now I have to get to 6:30. Can I just add 5 hours to get to 6? Sure. So then I'm at 6 o'clock, but he's still sleeping. He sleeps another half hour or 30 minutes. See how important these labels are going to be? And that's when his alarm goes off. Not sure, like me, I would set the snooze button again. So now I need to go back and let's put just the hours together. So 2 hours can go together with 5 hours. So that gives me 7 hours. Sometimes when we combine our minutes, if they go over 60, we would have another hour. In this case, we have 15 minutes and 30 minutes. That gives us 45 minutes. So all this great thinking on here, and other people look at this and think it's sloppy, and we know it's just great thinking that came together, but we need to record our answer in a way that another mathematician will understand what we did. So down here we have our sentence. Tom slept 7 hours, 45 minutes. And now it's complete. All right, here's another problem. Miss Ames' students go to the zoo for learning journey from 8:45 to 2:30 p.m. So 8:45 a.m. to 2:30 p.m. through lunch is what I'm thinking. How long is their learning journey? Let's read it again. Miss Ames' students go to the zoo for a learning journey. So this part just sets up what's happening. The data or the details that I need are right here. Here's my start and here's my end. The question I'm answering is here. That's what I'm going to put into a sentence. How long is their learning journey? So I'm going to start over here, there. Don't like that at all. Put in a complete sentence. The learning journey was, we'll break it into hours and minutes, like that. So let's start with our number line. So we know the start and we know the end. We want to know the duration, how long it lasted. So we're starting here at 8:45 and we end at 2:30. So notice again that we're going to get past that noon hour, so we're going to have to be prepared to cross noon. So I'm kind of thinking to get myself there. If you want, you could jump in 2 hours and 2 hours again. I'm going to go ahead and jump 4 hours. So I'm getting to the 12 o'clock hour, but not past it. That's helpful for my brain to keep track. So 4 hours. So 8 plus 4 is 12. Right? You agree with that? And the minutes didn't change, so those just slide over because I didn't change the number of minutes yet. So we go from 8:45 to 12:45. I need to get to the 2 o'clock hour, but if I add 2, I'm going to get to 2:45, and I don't really want to go past it, so I'm going to go ahead and just add 1 hour. So that gets me to 1:45. I want to get to the 2 o'clock because that's just going to make my life easier. So that would mean adding 15, label it, minutes. So that's at 2 o'clock. See how we use these different size jumps, and now our final jump would be for 30 minutes. And so we can see how long this lasted. So we're going to put the hours together. That would be 5 hours. And then we can put the minutes together. That's 45 minutes again. And then we can go ahead and fill it in on our inner sentence. There were, oh, I spelled that wrong. I hope you corrected me. This should be T-H-E-I-R. I apologize. Their learning journey was 5 hours, 45 minutes. Great. And that's it. That's all we're going to work on together today. Your workbook, page 157 to 158, just the odds, please. Review those with somebody at home. There's going to be a time problem on Seesaw. There will also be an exit ticket. Remember, as always, just use some scratch paper that you have at home. Write on anything will work, so you can practice showing your thinking before you try and put it on Seesaw. Those 6 math tile pages, work on them at your own pace, a little bit at a time. That's always good. Last week I had some students ask me questions through Seesaw when something didn't make sense. Feel free to do that, and I can do my best to help you out. Stop here and come back Thursday. Today on Thursday will feel a little bit like more of the same because we're going to continue looking at and practicing some story problems in real life situations involving time. Let's read this a couple of times and think about what's happening. Linda looks after her baby sister for 3 hours, 25 minutes when her mother goes shopping. How many minutes does Linda look after her baby sister? So let's read that again. Linda looks after her baby sister for 3 hours, 25 minutes when her mother goes shopping. How many minutes does Linda look after her baby sister? At first, you might kind of think they just told us how long she's watching her baby sister. But if you look at it more closely, you will see that right here, minutes. Up here in our problem, we have hours and minutes combined. So we actually have to convert those hours to minutes and add them with the other minutes. So let's write our sentence so we remember what we're searching for. How many minutes does Linda look after her baby sister? Linda, I'm just going to change it to say watches her baby sister for blank minutes. So here's what we have to remember. 3 hours. Each hour is 60 minutes, so I have that happening 3 times. 60 minutes, 60 minutes, and 60 minutes. So if I combine all those, I'll know how many minutes were in the 3 hours, but don't forget to go back up and grab that 25 minutes. So you might be thinking of 3 groups of 6 is 18. So 3 groups of 6 is going to be 180 because it's 10 times larger because we have that placeholder 0 there. Okay, so 180 minutes is the same thing as 3 hours. It's kind of like the other day when we were talking about 90 minutes being 1 hour and a half. So we have 180 minutes, but now we need to add our 25 minutes. Hopefully in your thought bubble, you're going, oh, 180 plus 20 is 200 plus 5, 205. So we have 205 minutes for the amount of time in minutes that she watched her baby sister. Next problem. Karen started making muffins for her brother at 1:30. She took the muffins out of the oven at 4:10. How long did it take Karen to make the muffins? So I'm assuming she didn't bake them that whole time, but remember, the whole process of putting the ingredients, measuring them, mixing them, so it takes a while. So she started making muffins at 1:30. She took them out of the oven, at 4:10. We're looking for that. It's how long did it take her? So we're looking for the duration. So let's write our sentence. Karen started making muffins for her brother at 1:30. She took the muffins out at 4:10. How long did it take Karen to make the muffins? So it took Karen hours, blank minutes. Ran out of room to say to make muffins. You could add that if you'd like. Let's go ahead and think about this. So for this problem, a number line is going to come in handy. And we know our start time is 1:30. We know that she's done taking them out at 4:10. So we can go, let's go ahead and jump ahead 2 hours. Labeling my type of jump, whether it's minutes or hours. So 1 hour ahead is 2:30, 2 hours ahead is 3:30. I could jump another hour, but that gets me beyond. So what if I jump a half hour or 30 minutes? There's at 4 o'clock. And then I can see that easy 10-minute jump. So don't forget to go back and combine the minutes with the minutes. You have 40 minutes there and 2 hours. So it took Karen 2 hours, 40 minutes to make the muffins. One more problem. Marion practices ballet for 1 hour, 30 minutes in the morning and 45 minutes in the afternoon. How long does Marion practice ballet in all? Give your answers in hours and minutes. So 2 problems ago, we gave our answer in minutes only. So they're telling us specifically that they want to see hours and minutes in our answer. So reading it again, Marion practices for 1 hour, 30 minutes in the morning and 45 minutes in the afternoon. How long does Marion practice ballet in all? There's our question. That's important too. Lots of details here. So let's write our statement. So Marion practices for blank hours. Remember, they want hours and minutes. Blank minutes. Okay, so let's go ahead. A couple approaches you could take to this. Some of you might be thinking of this 1 hour, 30 minutes, and remember from earlier, I said that's 90 minutes. So you could take your 90 minutes plus your 45 minutes and then figure that out from there. Other people are thinking, well, if I have 1 hour, 30 minutes, let me put it on number line too. And if you add 30 minutes to that, so if I'm thinking of my 45 and I broke it into 30 minutes, then I would have 2 hours, right? I need 15 more minutes. So I would jump ahead 15 more minutes. So now I'm at 2 hours, 15 minutes. So that's one way you could solve it. If you wanted to do this, you would get 135 minutes. You have to remind yourself how many minutes make an hour. So how many 60s can you take out of there? So I know I can take 160. How many if I take out another 60, that's 120. So I haven't gone over that amount yet. And then the number of minutes left that I have, I'm going to circle those because those are hours, would be 15 minutes. So you could solve that either way. And do you see how we came up with the same answer both times? So she practiced for 2 hours, 15 minutes. Try multiple ways. It's a great way to stretch your math brain. Thursday's work, page 163 to 167. It feels like a lot of pages, but they're kind of spread out. Just do the odds. Problem solving on Seesaw, and exit ticket on Seesaw, and those math tiles. Stop here and check back in on Friday for a couple more problems. Friday, last day of the week. We're just going to review 2 problems together, and then I'll ask you to do some practice on your own. All right, here we go. Mr. Cruz travels 2 hours, 40 minutes from town P to town Q. He travels 1 hour, 55 minutes from town Q to town R. How long does he travel altogether? Get that highlighter ready and highlight some important information for the second read through. Mr. Cruz travels 2 hours, 40 minutes from P to Q. Then he travels 1 hour, 55 minutes from Q to R. So we look here and we go, okay, how long does he travel altogether? Let's write that in a sentence. All together, Mr. Cruz travels, let's say hours, I'm running out of space, minutes, I'll write it down there. All right, my first step would be, I'm going to take this hour and that hour and put them together. I have 3 hours. Now I have 55 minutes and 40 minutes. Okay, so those went together. So if we look at this a couple of different ways, we can say 40 plus 55. So do you see that 40 and 50 is 90? So this is going to be 95 minutes. Which works, it's accurate, but we should take this out into how many hours? Is it more than an hour? You probably see that there are 60 minutes in there, and you can't make another group of 60, but there are 35 minutes left over. So this would get converted to 1 hour, which would then go with that 3 hours. Another way I thought about this, I'll write it over here, 1 hour. So together we'd have 4 hours. Did anybody else look at this and say, if I take 5 from here, I'm left with 35 minutes. If I add 5 to here, I'm at an hour. Remember to be that mathematical thinker that looks at things to help yourself. So now you can see that 1 hour and the 35 minutes. So we should answer this completely all together. Mr. Cruz travels 4 hours. Don't lose track. Put this hour with these other 3. 35 minutes. Nicely done. Last problem. A school choir practices for 1 hour, 45 minutes on Friday and 3 hours on Saturday. How much shorter than the Friday practice is the Saturday practice? So a school choir practices for 1 hour, 45 minutes on Friday, and they practice for 3 hours on Saturday. So what's the difference between 1 hour, 45 minutes and 3 hours? So you can almost think about, we can definitely think about this as on a number line. Oops, that was white. White didn't show up. We could think of it as 1 hour, 45 minutes and write it that way. And we want to know what the difference is to 3 hours by itself. Just thinking about it this way will help you to see that if you jump an hour, you would be at 2 hours, 45 minutes. And as we work in times in kind of that base 60, we know that only 15 more minutes can be added to get to that 3 hour mark. And right there, you can, oh, is anybody at home yelling at me because I didn't write the sentence? I just yelled at myself, but I don't want to start over. Let's see. Back to the question. How much shorter than Friday practice is Saturday practice? So let's say Saturday practice is whoops, forgive me. Let's see. Wrong pen. Friday's practice, because that was the shorter one, is blank hours, blank minutes shorter. That was a key word there. Okay, so we see that we moved ahead 1 hour here and then 15 more minutes. So because we had an hour and 45 minutes and then 3 hours. So do you see from that that the practice is 1 hour, 15 minutes shorter? All right, it's the end of the week. 163 to 167, so you're going back to the same pages, but just doing evens, kind of like we did with an set earlier in the week. Other pages in the workbook to finish this week are listed here, page 155 to 156. Those were split into even and odd pages. 2 separate days. Page 157 to 158, just the odds. Page 163 to 167. So we did the odds on Thursday, and for Friday's assignment, you're doing the evens. On Seesaw, there will be a problem-solving problem there for you to show me your thinking, an exit ticket, and you know what to do on those math tiles. We made it to the end of another week. Thank you for putting in such great effort and work, and I look forward to seeing and hearing from you on Seesaw and in our meetings.